This is your notes video for section 9.3. And what I want you to do first is turn to the very front of the Unit 9 white packet and fill in this formula that I circled in red for partial sum geometric. You don't have to write the other one down at all. The one that you see here, that is not widely used at all. They are equivalent, but the one that I circled is more popular. You can see it says preferred formula. And does anybody need me to zoom in a little on that? Sure. No. A little bit better? Okay, so this formula looks familiar if you look here. What does it look like if you just look here? Yeah, yes, it's very similar to the one that is infinite geometric, right? U1 over 1 minus r. And that was reserved for what kind of geometric series? What was the one little stipulation? Well, there were two. There were three. It had to be geometric, infinite, and something had to be special about r. Yes, yes. It had to be between -1 and 1, because if it went on forever, the only way it could have a sum is if it was convergent, meaning that the number that you're adding is getting close to 0. With this formula, however, any r goes. Okay, any r is valid. So you don't need r to be between -1 and 1. It could be anything. So what we'll do first is just a very short example. Just put it right underneath the box that you're working on right there. Just call it example. 1 plus 2 plus 4 plus 8. Stop at 8. What do you get? Can we do that in our head? You get 15. 1 plus 2 plus 4 plus 8 is 15. We know the answer. We're just going to use the formula to make sure we get 15, just to see if the formula works. All right, so a very basic example. Is this geometric? Is r between -1 and 1? It doesn't matter. It's 2, which is outside that range. That's okay. Does it have a finite number of terms, n? How many? 4. And what's the first term? 1. So let's check the formula. The sum of these 4 terms is u1 times 1 minus r to the n, 2 to the 4th, all over 1 minus 2. Remember, if this would have been infinite and r was less than 1, or bigger than -1, we would have only done 1 over 1 minus 2. When it's finite, you repeat the 1 minus 2 again up there, but you put the number of terms as its exponent. Okay? You could drop the parentheses in this case because u1 is 1. Okay? So let's go ahead and work that out by doing, what's 2 to the 4th? Anyone? So we have 1 times 1 minus 16 over -1. So we have -15 over -1, or 15, which we already knew. We were just checking out the formula to make sure that it worked. So this video will be called, if you want to watch it later, Intro to 9.3.